For as long as anyone can remember, the night sky has delivered the same impression. Stars are everywhere. They fill the darkness. They return every night. Nothing about them feels temporary. Then, astronomers began looking beyond individual stars and tracking how new stars appeared across the universe. The pattern did not behave the way people expected. When they reconstructed the universe's history, a strange pattern appeared. The universe was not gradually building toward a peak of star creation. It had already passed one. Billions of years ago, new stars were appearing far more rapidly than they are today. Then the activity began to slow. Not suddenly, not dramatically, but steadily. The result is a strange contradiction. The sky still looks crowded with starlight. Galaxies still shine. Bright stars remain scattered across the darkness. Yet, beneath that familiar view, fewer new stars are being added than before. The universe is still creating stars, but not as rapidly as it once did. The sky still looks full. The system feeding it no longer moves at the same speed. That changes something important. The age of abundant starlight stops looking permanent. It starts looking like a phase. And if stars still seem to be everywhere, what is causing the supply of future stars to shrink? The slowdown no longer looks like a temporary dip. Inside galaxies, new stars are built from cold gas. As stars form, that gas gets consumed. Some of it stops being usable. Some of it is driven away. Some of it becomes trapped in forms that no longer help create the next generation. The effect builds quietly from one generation to the next. Every successful wave of star formation leaves less usable material behind for the wave that follows. At first, that does not sound alarming. Galaxies still contain enormous amounts of matter. They still glow. They still appear rich with resources. But the important detail is not how much matter exists. It is how much of that matter remains available in the right condition. A factory can stand full of machinery and still slow down if the supply of raw material keeps shrinking. The same pattern begins appearing across the cosmos. Stars continue forming. The process continues. Yet each generation quietly spends part of the inventory required to create the next one. That changes the interpretation of the decline. The universe is not simply producing fewer stars for the moment. It is gradually consuming the conditions that make star formation possible in the first place. And that creates a deeper problem. If so much matter still remains inside galaxies, why can that matter not keep producing new stars indefinitely? That conclusion feels reassuring. After all, the universe is not running out of stars today. Across large galaxies, bright star-forming regions are still active. New stars continue appearing. Clouds collapse, new points of light ignite, and fresh stellar systems take shape. The process has slowed, but it has not stopped. Look across the cosmos, and the evidence seems obvious. Galaxies still shine. Star clusters still glow. New light is still being added to the sky. Even more reassuring, many of the stars that already exist are built to last for extraordinary lengths of time. Once formed, they can continue shining for billions, and in some cases, even trillions of years. That changes the emotional picture completely. A declining production rate sounds serious until the existing inventory remains visible everywhere. The universe does not look exhausted. It does not look fragile. It looks active, populated, and full of ongoing creation. If someone looked only at the visible sky, there would seem to be no crisis at all. Under that interpretation, the concern begins to fade. The final stars, if they ever become relevant at all, seem unimaginably distant. The cosmos still appears rich with light and capable of producing more. Which raises an uncomfortable question. If everything still looks so healthy, what evidence suggests that the long-term decline cannot be avoided? The confidence holds only as long as attention stays fixed on the stars that already exist. Look closer at what is actually happening. Across the universe, countless stars continue shining. New stars still appear. Galaxies remain bright. The sky still looks rich with activity. But those visible lights and the process creating future lights are no longer moving in the same direction. One is sustained by the stars that were already built. The other is gradually weakening. Every year, existing stars continue burning. They continue providing the appearance of abundance. They keep the universe looking healthy. Yet, beneath that brightness, the supply of accessible star-forming material continues shrinking. The contradiction is easy to miss. The night sky is showing the result of work that was done long ago. It displays billions of years of accumulated star formation. What it cannot show is how much weaker the replacement system has become. Imagine a civilization living comfortably on enormous savings. The lights stay on. Daily life continues. Nothing appears wrong. But if new income keeps falling while old reserves keep being spent, the visible stability begins hiding a different reality. That is the situation taking shape across the cosmos. The future remains bright because vast numbers of old stars are still shining. The deeper trend points somewhere else. New star production continues slowing because the material required to sustain it becomes harder and harder to use. The universe is not maintaining the same supply of future light. The light remains. The ability to replace that light is what keeps shrinking. More and more of the cosmos is being carried by stars that were created long ago. And reserves, no matter how large, eventually raise a difficult question. What happens when the remaining stellar supply is finally spent? The change never arrives as a single event. One star fades, others continue shining. Entire galaxies remain illuminated. For a long time, the loss appears insignificant against the enormous reserve of light already spread across the universe. But the balance keeps shifting. The stars that survive continue consuming their fuel. The stars that disappear are replaced less and less often. Each passing era contains fewer new sources of light than the one before it. The important change is not what vanishes, it is what stops appearing. The universe once produced stars far more rapidly. New light constantly emerged across countless galaxies. That renewal helped sustain an age of abundance. Over immense stretches of time, that renewal continues weakening. Old stars burn on. Replacement stars become increasingly rare. The sky remains bright because earlier generations continue shining. Not because the system creating future generations remains equally strong. Eventually, the pattern becomes impossible to ignore. the disappearance of starlight is not driven by a sudden catastrophe. It spreads because the creation of new light keeps falling while existing sources gradually exhaust themselves. The final stars do not mark the end of matter. They mark the moment when the universe stops replacing its own light. The lights that remain may continue shining. The age of creating new ones is over.